All right. So thank y'all for coming. Sorry about yesterday. Having some family issues that need to be dealt with. But yeah, so here we go. Okay, so in light of what we were supposed to cover yesterday and today, you can kind of discuss them in one big sitting, and that's what we're going to do this afternoon. So first we need to talk about polynomials and what makes up a polynomial. So in short, a polynomial is just one or more mathematical terms stuck together with addition and subtraction. But it has to follow two basic rules. So all exponents on variables are both positive and whole numbers. Okay, so this is kind of a shortened way of saying it. The more technical definition means that there are no variables that are in the denominator, and there are also no roots or radicals with variables. But given what we talked about before, a negative exponent, so x to the negative n, we said, sorry, I'm still trying to get my camera stand and everything to a good place. X to the negative n is 1 over x to the n. So that first one means that you're not dividing by any variables. Okay. And the whole numbers for the exponents, like we said, x to the 1/2, or we'll just do n. So x to the 1 over n is the nth root of x. Okay, so a polynomial is just a set of numbers and variables that follow these rules. You aren't dividing by any exponent, or I'm sorry, by any variables, and you also don't have any roots of variables. So the simplest polynomial, and it's kind of a boring one, but it is, would just be a number, 7. That is a polynomial, because there are no variables that have a negative power, or you could say are dividing by a variable. And there are no roots of variables because there are no variables, and that is allowed. Another way of thinking about this is something like this. What is x to the 0th power? Can anybody tell me that?
Should be 1.
It's 1. Yes. Exactly right. So anything to the 0th power is 1. So 7, you could write as 7 times x to the 0, because that's just 7 times 1. And this is always true. So it's something that's kind of, we don't often talk about, because if we don't write it, then we usually just kind of ignore it. But it is helpful to understand what's happening. So you can build these polynomials up by just attaching different numbers and variables together. So you could have, I don't know, 3x squared y to the 1st or something. That's a polynomial. Another polynomial, I'm sorry, you can also add a polynomial to another one, and it is just a new different polynomial. So plus 2x, something like that, okay? So this is just one big polynomial, okay? And again, it just follows these 2 rules. If there is an exponent on a variable, it has to be positive, and it has to be a whole number, okay? So, sorry. So what? Who cares, right? This is a common thing that we do in math, is we create a new kind of object. The first objects we talked about were numbers. And usually little ways down the road, you start talking about just variables by themselves. And we look at the qualities of those things. We look at what processes can we do on them? Can we add and subtract them, multiply, divide, that kind of thing. So here we're doing the same thing. We want to look at what can we do with these polynomial objects. Okay, so we'll start with simple ones. Does anybody remember what is the first process we said that you could do on numbers? What's the first thing that you can do with numbers? Sounds like really elementary level stuff, but it's important to kind of see the progress of this stuff.
Add?
Even before that.
Sequences? What are you referring to?
So, and this is why I say it's even simpler and almost middle schooly or elementary schooly. Let's say we have 2 numbers, 2 and 5. What can we do with these 2 numbers? It sounds silly, I know, but before we add and subtract things, this is also true of stuff in general. you can compare two things, right?
Okay. Yeah.
So does 2 equal 5?
No.
No. So the first thing that we can say is this thing is not this thing. Same thing with polynomials. We can say that 3x is not, I don't want to write equals because it might be a little awkward, but 3x is not the same as 4x squared or something, right? The first thing that we can do is look at polynomials, compare them, and see if they are the same or different. So this is, like we said, it's the simplest thing that you can do, and is actually an important thing when you get to higher levels, is you need to be able to tell if two things are different. So you kind of need to define like how they're different. But anyways, getting into it, after we can compare two things, I think you had it, Isaiah. What is the next thing that we can do?
I guess it'd be add.
Yeah, combine two things. And it's the same thing with polynomials. Okay, so I'm just going to use x as a variable here, but please understand that it doesn't matter that it's x or y or t or some other symbol. That's just it's kind of a placeholder. So the fundamental idea works with all of them. So give me a polynomial. Doesn't have to be a complicated one. Simpler the better, to be honest.
3x squared.
3x squared.
Y to the first.
So we'll do x to the first because I just want
Okay.
x's right now. But you're not wrong. That would have made a fine polynomial, but I am trying to kind of keep it simpler so we don't just, go crazy. And this is actually a really good example. So 3x squared plus x to the first power. What do we get here?
Well, I get that is the answer.
That is the answer. Why is that the answer?
I guess combining like terms, it's only one x, an x to the first, and there's an x squared.
That's exactly right. This is where we get into combining like terms. And that's what the first section is about, is understanding, okay, what makes things like each other. So like terms have, the same variables to the same degree.
Nope.
Also known as power. All right. So what were you saying?
No, I was about to say no pun intended, but I don't know. Yeah.
No. Yeah, it's as simple as that. Things that are like basically all of the things that aren't the big number out front, sorry, have to be the same. Okay. So a lot of people get in this weird situation where they see something like this and they say, oh, that must equal, you see all sorts of things, 4x squared, or you might see 3x to the third. Uh, it just kind of depends on who's the one answering the question. They will give me something that's a little bit different. And so these are the adding rules for exponentials. Okay, we talked about this on Tuesday, whenever the last time I was on was. When you have two things, you can only add them together if they have perfectly like terms. So, yeah, so these things don't combine. You would have to have, if it was 3x squared plus x squared, this has the same variables, they both have x's, and both of those are x to the 2. So there, you can combine those. What do those two combine to be?
4x squared.
Yeah, so it's a basic counting problem, really. There are 3 x squareds and 1 x squared. So if you put them together, 4x squared. And in my normal classes, when we have a little bit more time, I usually like to try and compare variables to like the units of something. And that usually helps people see what you are and aren't allowed to do. Taking this, for example, 3 meters squared plus 1 meter to the first. So we'll go ahead and put a 1 up here. Just,
You mind moving your paper up just a little bit?
thank you.
Thank you, sir.
So this would be that first example, but we're talking about meters or inches or feet, whatever you want. But meters squared or feet squared and feet, what is the difference between these two things? What kinds of things do you measure in meters or feet? So you measure distances in meters or feet or whatever, or you could say lengths. But what do you measure in meters squared or square meters, square feet? What does that measure?
Well, basically to be the area.
It's an area. Yeah. And so what you're doing here is you're trying to say you're adding some area plus some length. And that doesn't make any sense, right? Like they aren't in the same I mean, you could kind of think about, they're not the same dimension. That's what these are, is dimensions. But they can't interact together because they don't have the same units to the same power. So if that helps you to think about when you're combining things, everything after that coefficient, that big number up front, has to be exactly the same. So that's an important factor to start. But after you get past the initial discussion of, okay, are those variables the same with the same powers? Then you just add the front, and it's what most everyone has done, combine like terms. And that's really the only kind of addition or subtraction that we even talk about when it comes to polynomials and stuff. So that is what we do about addition and subtraction. Well, what else can we do? We know we can add and subtract stuff.
Multiply.
We can multiply stuff, yeah. So just like we've talked about before, multiplication is repeated addition. So if you can add something, then you should be able to multiply it to some extent. Okay. So let's talk about multiplication. I'm going to take two very simple ones. 3x times, I don't know, 2x. Okay. So when we see something like this, how do you know how we go about it, or where we might start? So let's break up what these things actually mean. Remember, 3x is just a shorthand way of saying 3 times x. So really, this is 3 times x times 2 times x. Multiplication has this fun little fact about it, where if you are multiplying a bunch of things together, it doesn't matter what order you do it in. So we can just get rid of those brackets and multiply everything. So 3 times x times 2 times x. And here, we just kind of put things together in a, as nice and neat of a fashion as we can. Usually, we put all of the numbers together up front, and then we do alphabetically all of the variables. I don't expect to see like each of these steps, but this is kind of what's happening here. So 2 times 3 times x times x. And then we can go from there, right? So the 2 times 3 simplifies to 6. And what we talked about with exponents, x times x, what's a better way to write that?
X squared.
Yeah. So, sorry, I was getting a tell. Yeah, so this is 6, and there are 2 x's, and that's how we do it. Okay, so whenever you're just multiplying simple polynomials together, you just combine the numbers together into the coefficient up front, and then put all of the like variables together. All right, so if we take this up kind of a notch, we get multiplication of polynomials becomes very, very involved sometimes. So let's change this around and say our first polynomial is actually x plus 1. And our second polynomial is 5x. Okay. Well, what do we get here? So
5x squared plus 1.
not quite. So we have to look at
Oh, okay.
what would happen if this was not a variable, but let's say a number. Let's say this was 3 plus 1 times 5x.
Oh, yeah, I'm sorry.
What do we get? Well,
So
what
it'd
do we
be
get there?
5x squared plus 5x.
Yeah. So in this case, you could combine it and it would be 4 times 5x or 20x. So another way you could write that before going into this step is 3 times 5x plus 1 times 5x. Remember, you have to distribute things about. So if we distribute in the first one, like you said, 5x times x plus 5x times 1, which is 5x squared plus 5x. So this is where things kind of start to get, like I said, a little involved for some people, and it's okay. As the number of terms kind of balloons, it is difficult. It's weird, and that's okay. So don't come down hard on yourself for not immediately getting it all the time. But just follow the basic rule, and I'll show you this rule as we step up to the next level. Let's try and I will go ahead and say that for my class, this is a B, not a 6. I'm sorry, my handwriting is not always great, and that's just how I do my Bs. But if I do a 6, it will be like very obvious that the top is way over the side. But if it's directly on top, then it's probably a B. So just a fair warning on that one. But x plus a times x plus b. What are we going to do about this big ugly thing?
You would do the foiling process.
Yeah, so that's how most people tend to deal with this kind of problem is, like you said, FOIL. First, outer, inner, last. So you do the first term in each one. So x times x. The outer two terms, x times b. The inner two terms, a times x. And then the last two terms, a times b. So what you get is x squared plus, I usually put the letter first, bx plus ax plus ab, right? So nothing too crazy. And if you like the FOIL method, that is the one that you will be using. The kind of thing that you'll be doing the most is um, it's called binomial expansion, because there are two terms in here and two here. So it's the binomial. But trying to memorize the FOIL thing, I've found is very kind of confusing for people when they see one that is different. So what about x plus y plus z times a plus b? So what do we do here?
First distribute the A to everything on the left, and then do the same with B.
So yeah, you're getting right at it. The idea here is that you're going to combine everything in this set of parentheses with everything in this set in every possible combination. But X can't combine with Y or Z because they're in the same set, and A can't combine with B because they're in the same one. So like you said, A goes to X, goes to Y, goes to Z, and B goes to X to Y to Z. So you get AX plus AY plus AZ plus BX plus BY plus BZ. So that's nice. What happens when you get X plus Y times A plus B times, let's say, M plus N? So this shows even more where the FOIL method really kind of falls apart. So in this case, what you have is you can't just distribute the A to the everything else and then the B. It doesn't quite work that way. But all you do is you take something out of each bucket and you combine those three things. And then you do the same thing again, just changing one. So you can do the first ones first: X, A, and M. Well, now we could do X, A. We already did M, so let's do N. Well, we did X, A's, so let's do X, B, M. And now we can do X, B, N. And then you do the same thing with Y. And you won't see these a lot in this class, but they are definitely going to be coming up, I guess is the thing to say. Especially the further you go, it's important to understand what's actually happening. So, like I said, you can memorize the FOIL rule if you want to just memorize processes, but remember it's this combination thing, and it is actually the same all the way up here, very beginning, well, we combine everything in this parentheses to everything over here. So we do this one and this one. But there's only one in each parentheses, so we're done. There's only one combination to happen. And then here, we combined the first one with this and the second one with this. So if you don't like to memorize formulas and you like to kind of think about the idea behind it, which is what I suggest because it will benefit you more going forward. But again, kind of up to you. So won't have enough time to get to it today, but up to now, every time we talk about a process, it's also important to talk about the opposite process. Opposite of addition is subtraction. Opposite of multiplication, when you're talking about numbers, we usually say division. It doesn't exactly work out quite like that in when we do it with polynomials. It's not just division. What it is called factoring. Factoring is a big deal. So what is a factor of a number? Well, A times B equals C. A and B are factors of C, meaning A and B are numbers that you can multiply to get C. And the other way around, C is a multiple of A and B. Okay. So the first thing that we did on the other page, multiplying, is when we were taking two different polynomials, multiplying them together and getting one big one. Factoring is the other way around. So factoring takes 5x squared. About to get cut off here in a sec, but finish up this last little bit. 5x squared plus 5x, and factoring that into 5x times x plus 1. And this is a simple kind of version where you just see, okay, you can take both of these have a 5 you can divide out, and then they both also have a single x you can divide out. But we will talk more about this factoring business tomorrow. I'm probably going to do a morning session as well, just because I have some catching up to do, and I'm trying to work around all of your test stuff, and I will send an email out about how that's going to work, just because I know things have been rough from my end this week, so I'm trying to fix that for y'all.